Integrate sin inverse root x minus cos inverse root x upon sin inverse root x plus cos inverse root x with respect to x. With reference to these various types, let's now try to integrate this new function. We have an identity in trigonometry, inverse trigonometric function. Sin inverse x plus cos inverse x is pi by 2. Since it is an identity for any x, this relation will be true. So sin inverse root x plus cos inverse root x will also be pi by 2, from which we can write cos inverse root x is equal to pi by 2 minus sin inverse root x. Both of these we are going to use in this integrand. The denominator is straight away, according to this identity, the denominator is pi by 2. And this cos inverse root x will also be changed in terms of sin inverse root x. It will look like this. Simplify further. Sin inverse root x minus sin inverse root x is 2 sin inverse root x minus pi by 2 and the denominator. We will separate it into two terms now. Pi by 2 upon pi by 2 is the second term, that will become 1. And here we have 2 sin inverse root x upon pi by 2 will be 4 by pi sin inverse root x. We have two terms to integrate, out of which second one with respect to x we can integrate easily, as integral of 1 is x. That we will do at the end. Right now, let us concentrate on this integrand. For that, I am writing the two integrations separately. And we will go for integration of this function. How to integrate this? Though it is a single function, we do not have a direct formula for sine inverse functions integration. Here, we will go for a substitution. Let theta is equal to sine inverse root x. The whole function we are going to take as theta. But then what about dx? We should go for dx. For that, I will first change the simple substitution into this. Root x equal to sine theta. X is equal to sine square theta. Now let us find what is dx. Dx is to be differentiated according to the chain rule here. 2 sine theta into cos theta will be the derivative of sine square theta by chain rule. And 2 sine theta cos theta is nothing but sine 2 theta. So, we will be able to replace the dx by sine 2 theta d theta. And sine inverse x as, sine inverse root x as just a theta. So, this integrand would now change to this form. Theta is sine inverse root x and sine 2 theta d theta is the dx here, the dx. So, the integration is now in this form. The second term as it is copied. The coefficient 4 by pi is there. Now, what kind of an integration is this? We have a product. Product of an algebraic function and a trigonometric function. Remember, we are integrating with respect to theta. So, according to that, this theta is an algebraic function. So, we will go for the product rule. Integration by parts. It says first function into integral of second minus integral of derivative of first into integral of second with respect to x. Let's apply it. While applying, we need to write the first function into integral of sine 2 theta. What is integral of sine 2 theta? We need to write that integral in the formula itself. So the formula we will take from this form. Sine 2 theta integral is minus cos 2 theta upon 2 according to this formula. Minus cos ax plus b upon a, this direct pattern, without showing the substitution. So, minus cos 2 theta upon 2. And twice we have to apply that integration in the formula. Integral of second, again integral of second. Both time we apply the same formula. Now, to simplify further, let's go. This part has to be integrated once more. Luckily, it's no more a product because of this 1. So now how will you integrate this? We need to integrate it with respect to theta once more. Again by the same formula. Cos 2 theta by 2. Cos 2 theta by 2. Cos 2 theta. Integral is sine 2 theta by 2. Here it is. That one more 2 makes it 4. And by this time, since the integration of this part is over, let's complete its integration also. Integral of 1 is x. Here we are. The complete integration is over. Now what to do? We have to simplify. We cannot leave the answer in terms of the variable that we have brought in. We have to replace it, the x variable. How? Through the substitution itself. And the substitution is through a sine function, and we have many cos functions here. Let's see what do we do. Cos 2 theta is 1 minus 2 sine square theta. Our intention is to get back to sine theta so that x can be replaced. So cos 2 theta identity 1 minus 2 sine square theta. And sine 2 theta is 2 sine theta cos theta. Again, one more cos theta is left. By the time, let's do little simplification also. 2 and 4. Here 2. Then the LCM is 2 here. That 2 half we can take out and make this 4 by pi as 2 by pi also. 4 by pi, we will make it 2 by pi in the next step. This 2 because here 2 by 4, 2 and 2 here, LCM. Also, we need to change this cos theta. Cos theta is changed into root of 1 minus sine square theta. Now, the complete function is now in terms of sine theta, so that we can easily replace the variable x. Sine square theta is x. Sine theta is root x. Again, sine square theta is x. Replace all that, the answer will look like this. Theta itself is also present there, which is sine inverse root x. This theta is sine inverse root x into 2x minus 1 plus root x into root of 1 minus x. One more step simplification over this. We can put this under same radical sign. It will look like this. Root of x into 1 minus x is x minus x square. And rest is the same. Here we go. Found it useful? Don't forget to subscribe Merit Joseph channel for variety of examples and various topics.